At Quantum Formatics, we're leveraging an AI-accelerated superconductor discovery algorithm that essentially reduces the decades-long process of finding new superconducting materials to a few days. And our goal is to commercialize next-generation superconducting wires to give a route to accessible MRI machines and scalable fusion energy. So with superconductors, they really are kind of the material of the future. The real challenge is when you look at the commercially viable or commercially used superconductors, you essentially have two choices. You can opt for a low temperature superconductor, which is easy to work with because it's ductile, but as the name infers, you have to operate at extremely low temperatures. Alternatively, you can use a high temperature superconductor. The challenge here is that because they are brittle, they're extremely difficult to work with and difficult to manufacture, which leads to a very high material cost for adopting a high temperature superconductor. What we're trying to find is a ductile superconductor that operates at reasonable superconducting temperatures. We're able to increase the operating temperatures of MRI machines, and this allows a route to accessible MRI technology in developing countries by reducing the dependency on helium, as well as reducing the operating expenses associated with the cooling. So in our pilot run, we can screen about 200,000 materials per day using AI. We then reduce this list down further using quantum mechanical simulations. And there we can run about 100 to 200 materials per day. And then when we actually synthesize them in a lab, we can make between 1 to maybe 5 materials per day. And the real acceleration happens in that we're able to look at a broad region of the material space, which you couldn't do with a human intuition alone. And that allows us to search this broad space and whittle it down into the most promising new or novel materials to investigate further for superconducting properties. So this work was born out of a multi-department collaboration between the Department of Material Science and the Physics Department. And what that allowed us to do is have collaborations both on the theory of superconductivity, the development of AI models for materials discovery, as well as experimental collaborators that had expertise in superconducting synthesis and characterization. And the critical aspect or resource available at the University of Florida that enabled this work was access to extensive compute through the university's supercomputer, Hypergator. I want to thank Richard Hennig for being a world-class advisor and giving me the freedom to explore the research in the way that I felt was best suited to move the project forward. And I also want to thank my wife for continuously supporting me through all of the endeavors I decide to pursue.
They developed a really unique method to make new superconducting materials. So it's kind of a two-part invention. The first part being that they have combined an algorithm and machine learning and AI to predict what are going to be high-performing superconductor materials, and then they're taking the ones that look very promising, and reducing the practice of making and testing those. They've signed an option. They have are working very quickly to finish the licensing, and then they already have a major investor that's going to invest.